if z is equal to e to the 2 pi I over 5, then 1 plus z squared plus z cubed plus, and so on, is equal to which of these quantities? Okay. It's interesting that they have these strange coefficients here, but I mean, I intend on solving this probably through geometry. Z is one of the roots, one of the fifth roots of 1. So if I write this as z is equal to e to the 2 pi I over 5, then z is about here. So that's z. Z squared, z cubed, z to the 4, and z to the 5. We can also figure out higher powers as well as we need them. And so maybe I want to group these in a way where I know what the sum of certain things are. I'm not sure. Well, I know if I add z to the 1, z to the 0, 1, 2, 3, and 4, if I add those up, I get 0. So what I might do is manipulate the equation a bit. Oh, first of all, let's do this. 1 plus z squared plus z cubed plus 5z to the 4 plus 4z to the 5 plus 4z to the 6 plus 4z to the 7 plus 4z to the 8 plus 5z to the 9. So I'm going to write these first in terms of powers of z only between 1 and 4. So z to the 5 is 1, so that's a 4. Z to the 6 is z. Z to the 7 is z squared. Z to the 8 is 5, 6, 7, 8 cubed. 5z to the 4. Now we can group stuff together. 5 plus 5z. Z squared has 5. Z cubed has 5. I'm going to write this as 5z to the 4 plus another 5z to the 4. So if I add those together, I get 0. Because, I mean, if you look at the geometry, they're perfectly symmetric around 0. So if you add them all up, you get 0. So this is equal to 5z to the 4, which is 5e to the negative 2 pi I over 5. Is that one of the options? No, but you could also write this as this might be I think it's the same as option E. So if I take the negative of this number, I get something up here, which is going to be, the angle of that is going to be pi divided by 5, which puts me about here, times 3, something like that. So I believe this is just negative 5 e to the 3 pi I over 5. Pretty sure. Pretty sure that's correct, which is option E. So maybe another way of seeing this, 5e to the negative 2 pi I over 5. If I multiply and divide by 1, negative 1, or let's just call this negative 5, times e to the pi I over 5 times e to the negative 2 pi I over 5. So that's negative 1, right? No, it's not. Oops. Should be just times pi I. So we have e to the 5 over 5 minus 2 over 5 pi I. Yeah, which is 3 over 5. So that's the answer. Nice little problem. Definitely helps to visualize it like this so you can understand, well, either this or just knowing algebraically so well that when you have roots of unity like this, a lot of things raised to a power are going to give you another power, and that when you add them all up, you get 0. Don't think I have any mistakes in this one, but I'll let you know if I do. Thanks for watching.